dynamics, which is about force equals mass times acceleration. So we'll do rigid body particles in this chapter, and the next chapter it's going to be rigid bodies. Okay, so brief overview before we get to problems. Okay, so this chapter is essentially about applying Newton's law. Newton's second law, which states that force equals mass times acceleration. Okay, so far we've not looked at any problems where there was a force involved. We only looked at problems where we were either given positions or velocities or accelerations. Forces were not given. Now, in this chapter, we will see where forces are given to us, and we will find accelerations from the forces. And once we find accelerations, we can do all sorts of things we did in the two chapters we talked about. That is, find velocities, find positions. So, what's F, M, and A? F is the external force. M is mass of the particle, and A is the acceleration. Okay, we'll confine ourselves to two-dimensional motion. So acceleration is a vector in ij, and similarly force is a vector in the plane, so ij. So example of external forces are gravity, just force acting on the particle, spring force, friction. Okay. So when you see a problem where, and I'll tell you how to decide whether to apply Newton's law or not, you'll follow the following three steps. So I'll tell you the steps, and then when we solve the problems, I'll tell you why this problem is a F equals ma problem. It's not a problem related to kinematics only. So here is the algorithm to solve any problem, and this is how you can ensure that you get a good score in the exam. That is, all these steps are very important because we grade you based on these steps. So first step is draw a free body diagram. Okay, always do that because we always give partial credit for free body diagram. Okay, and I'll talk about what is a free body diagram. So this is actually a pictorial representation of all the forces, and on this diagram you should show. We won't call it FBD, free body diagram, because we'll just abbreviate it as FBD, and I'll just say FBD henceforth. So FBD should show all external forces on the particle. Okay, only the external forces. You're not allowed to show MA. MA, mass times acceleration, is not an external force, it's an internal force. The second thing is you got to write equations of motion. Write equations of motion. By that I mean simply write F equals ma, where that is actually not one but two equations, because you can write that equation in the x direction and also in the y direction. That F, a vector, indicates that it's in the I and j component. It has an I and j component. And then finally, the third step, and this is optional, it depends on the problem you get, is to solve for the velocity or the position by integrating equations of motion. Okay, so this is something which we've sort of done all through chapter 12, which is we found acceleration, or we were given acceleration, and we were told to find velocity and position. We clearly did one of the two. We either used a constant acceleration formula or we integrated if the acceleration is not constant. So that's the recipe, and I'm telling you that people do not just ignore this part. They just jump into step 2, and what that causes is that causes a lot of problems because you forget some forces. You do not get partial credit for this one. So I highly recommend that you got to draw a free body diagram in all the problems. Don't ignore them. Okay, so let me illustrate that the 3 steps by just solving some problems today. Okay, so write the equations of motion in the x and y direction for the 10 kg block. Okay. Okay, I've not told you what mu k is. Mu k is, this is the coefficient of kinetic friction. So when an object is in motion, the friction force, write it here, friction force is equal to mu k times the normal force. So let's call the friction force Ff mu k times n. What that means is if there's a block, okay, n is the normal force, mg is the weight, mass times gravity, then the friction force is mu k times n. So there's an aside. Now I've made an assumption here. I'm assuming that the block is moving to the right. Okay. When the block moves to the right, friction force always opposes motion, so it's going to be a sort of retarding motion. So it's going to act towards the left. If the mass was moving to the right or to the left, then friction force would oppose the motion. So there's an assumption here that the mass is moving to the right. So that's how you use the coefficient of friction. Okay, so in this context, let's use the three steps. First step is draw FPD. Okay, so when you're drawing the FPD, it has to be, so it's called a free body diagram. So you take the body and you free it from any surfaces or any things it's connected to. In this case, the body is connected to the ground, not really connected, but sliding on the ground. So you want to free it up from any other external object. So I freed up the particle or the block. Now I'll replace the effect of the inclined plane with a force. So the inclined plane exerts a force in the normal direction. So that's the effect of removing the inclined plane. Now we need to also figure out the external forces on the particle or the body. So gravity is not given here, but there is gravity. So gravity figures out in the vertical direction, downwards. So given the coefficient of friction, so there's going to be a force of friction. Now, how will the force of friction act? Will it act? So it's clearly going to act in the direction of motion, right? This way. But will it act upwards or will it act downwards? It upwards, because obviously this block is going to move down. So friction is going to oppose motion. So friction is this way. Let's call that FF. Okay. Okay, sometimes you're not given a coordinate frame. In this case, you are given a coordinate frame, so it's okay to put it there. But sometimes you're not given that and you need to create your own coordinate frame. Now, there are multiple ways you can have a coordinate frame. One way is to assume that x-axis is along the inclined plane, but another legitimate option is to assume that x is along the horizontal, y is along the vertical, and that's fine too. The reason why you want to use x along the incline is because you notice that two forces, N and FF, are along the, well, one of them is normal and one of them is along the incline. So you want to choose a coordinate frame so that majority of the forces are along that coordinate frame, so it makes it easier to write equations. Okay, but the other option is also valid, that is y upwards and x along the horizontal. Okay, so that is the free body diagram. Am I missing any forces? Yeah, so mass times acceleration will also show up some point of time in the equation, but you're not supposed to put it there. Okay, do not put it there. So the second step is write the equations of motion. So that's really writing F equals ma in both directions. So we can write Fx. So let's write Fy first. The net force in the y direction is mass times acceleration in the y direction. So the net force in the y direction. So since y points upwards, the normal force is going to be positive. Okay, I need to resolve mg along the incline and normal to the incline. So if this is 30, this is the vertical, this is going to be 30 degrees, right? Because this is the horizontal, this is along the incline. So this is going to be 60 and this is going to be 30 degrees. So this angle here is 30 degrees. Yeah, so we need to write mg along the y-axis is going to be mg cosine of 30 degrees. And what's the sign on that? It's negative because it points along the negative y direction. What's the acceleration in the y direction? It's positive. Okay, so acceleration in the y direction is 0. Okay, if the particle had an acceleration in the y direction, it will just fly off from the incline. That's not true. It's not moving along along the y-axis, right? So it's 0. So that's the first equation, n equals mg cosine of 30 degrees. So next equation is Fx equals mass times acceleration in the x direction. So the force is, so what's the force? So there's friction force, which is acting in the negative x direction. Is that it? There's mg sine 30, and that's going to act in the positive direction, this way, equals mass times acceleration in the x direction. So acceleration in the x direction is not equal to 0. Now some people like to write this as mass times x double dot, which is same as m d square x dt square. So I'll call that equation 1, call that equation 2. So I need to relate, I need to get rid of friction force. So FF is mu kn, which is from this equation here, is mg cosine 30 degrees. Let's call this 3. Okay, so we can put 3 in 2, which is this equation. So the mass cancels off. We're left with x double dot is minus mu kg cosine 30 degrees plus g sine 30 degrees. So mu k is 0.2, cosine 30 I think is sine 60, so it's square root 3 divided by, so it's 0.866.
Is that mu k times 10 or to the power of 10?
It's times n. Yeah. So 0.1 so minus 1.7 plus 4.91. This gives me x double dot equals so what comes out is that the acceleration is a constant. It's positive, which means that the acceleration is in the downward direction. So it's the block is accelerating as it's going down. So a follow-up question could be, find the velocity of the block after say n seconds, and then you'll have to use this formula in the constant acceleration formula, s equals s0 plus v0t plus half a squared, where a would be this, not 9.81, this. That's all it. Okay, so I just used steps 1 and 2 because we are asked to find the equation of motion, which is this. Equation of motion would have x double dot. We're not asked to find velocity or position, but if we were asked, then you can go from here, either integrate or use the constant acceleration formula. Okay, is that clear? So that's how we go about solving problems. Okay, next question. A 40-pound suitcase slides from rest 20 feet down the smooth ramp. Okay, the key word here is smooth. When you're told that the ramp is smooth, it means that the coefficient of friction is 0. Okay, there's no friction. Determine the point where it strikes the ground at C. Okay, that is equal to find R. And how long does it take to go from A to C?
This is going to be on this test.
This one, no.
No, but what we're going to do.
No, no. Okay, so in this particular problem, it's actually a mixture of what we, something new, which is F equals ma from A to B, but from B to C is something which we've done in the past. We've studied motion of a projectile, and that's what we got to know how to we'll apply that from B to C. So if you want to find R, right, we only need to find the velocity at point B. If you can find the velocity at point B, then we have actually figured out how to find R, because we've already learned how to find R given velocity and given the angle of launch, which is 30 degrees. The second question asks you to find the time it takes to go from A to B and B to C. We can find the time it takes from B to C from what we've learned in the previous chapter, but we've not yet done how to solve for time from A to B. But it's actually not hard, because in the previous question, remember, I solved for acceleration for a block sliding on an incline. If you're given the acceleration, you can find the velocity, you can find the time, so on. So we'll sort of combine that, what we've done in the previous question, with what we've learned in chapter 12 to solve this problem. So this is how we do solve the problem. We're going to break up this problem into two parts: motion from A to B and motion from B to C. So sliding motion from A to B, and then projectile motion from B to C. Okay, so let's do A to B. Okay, first step is draw free body diagram. So for the free body diagram for this box is going to be this. Let's call that I'm going to call this X prime and Y prime. And the only reason I'm going to do that is because I want to use two coordinate frames to solve this problem. When the particle is on the incline, I want to use X prime, Y prime. But when the particle is, or the box is moving from B to C, I want to change my coordinate frame, and I use this coordinate frame. Okay, so it's okay to switch coordinate frame as long as you're consistent. And that's just because, as I showed you earlier, it's more convenient to do it this way, to have a coordinate frame along the incline. So let me draw the forces, external forces on the box, mg. There's no friction, so that's about it. So this angle here is going to be 30 degrees, like we saw earlier. Equation of motion. So we could write the equation in the y direction, but really there's no point in doing that, because we're not interested in solving for normal force, because friction force is 0. So I'm going to just write that in the x direction. Fx is mass times x. I'm going to call this x prime double dot, just to indicate that it is in the x prime direction. So net force in the x prime direction is mg sine 30 degrees equals mass times x double dot prime. Okay, so you can get rid of mass, get x double dot prime is g sine 30 degrees. So do you guys know what gravity is in FPS system? 32.2. So it's 32.2 times sine 30 is half, so it's 16.1 feet per second square. Okay, so given the acceleration, now what I need to do is I need to find the time from A to B. That's part one. Other thing I want to do is I want to find the velocity at B, because if I can find the velocity at B, then I can find this range. So I'm going to try to find the velocity at B. So velocity of, so how can I find the velocity at B? I know the acceleration, and I know the distance. It's 20 feet. So is there a way that can relate the velocity, acceleration, and distance? Say that again.
Acceleration times the derivative of positioning velocity times derivative of velocity.
Yeah, so VdVds, yeah. So you could use VdVds, but when the acceleration is constant, you can actually, there's a formula in the book. You probably used this in the past. Right? The relation between velocity and distance is this. V square is V0 squared plus 2ax. So Vx squared is unknown. So it slides from rest, that's given to you. So the initial velocity is 0. The acceleration is what we computed here. It's 16.1, and the distance is 20. So Vx is, if you do the math on that, it comes out to be 25.37 feet per second. Okay, so that gives me the velocity at B. I also need to find the time from A to B, because I'm asked to find the time from A to C. So I can find the time from A to C by finding the time from A to B and B to C. So to find the time from A to B, well, if you know the velocity, then you can use this formula, Vx0 plus AT, right? Vx is 25.37, Vx0 is 0. This time is actually the time from A to B. A is again given here, it's 16.1. So T A to B is 1.57 seconds. Okay, so now we are in a position to continue solving for other things, R and time from B to C. So this was A to B. Now I'm going to look at the motion from B to C. So what I know is the velocity is 25.37, right? I found that out here. I also know the angle, this is 30 degrees. So angle made by the velocity with the horizontal is 30 degrees because of this 30. I know that this is 4 feet and this R is unknown. I need to find where exactly the particle hits, or what that R is. I also need to find the time, right? So given the fact that the vertical distance is 4, I can use the corresponding formula which we did previously, right, in motion of projectile. So if you're given x or given y, y0 plus v0 vy0t plus half at square. That's the formula for constant acceleration. This is motion under gravity. So initial y is 0. The final y is 4, and it's negative because this is my new coordinate frame. So y is downward, so it's negative. what's the velocity along y? This is the velocity which is in this direction. It's at 30 degrees. So the velocity in the y direction is 25.37 times sine of 30. And it's negative, right? Because it's pointing downwards. So 25.37 sine 30 degrees. T is unknown. What about gravity? What's A? So gravity is downwards, right? It's negative 32.2 times t squared. So only unknown here is time. So solve for t. Okay, I want you to go and understand how to solve for t, because this is a quadratic equation. You have to use the quadratic formula. You get two roots. One of the root will be negative, and time cannot be negative, and so the other root should be the actual time. So the time comes out to be, and this time is time BC. It's 0.2413 second. Okay. So once you get time, we got to find R. So we use the other formula, x equals Vx0t. So x, or in this case x is R, equals Vx is 25.37 cosine of 30 degrees times the time, which we already found, it's 0.2413. So if you do this calculation, you get the range is 5.3 feet, and total time is time AB plus time BC, which is 1.57 plus 0.2413 equals. Okay, cylinder B has a mass of m and is hosted using a cord and pulley system shown. Determine the magnitude of the force F here as a function of the block's vertical position y, so that when F is applied, the block rises with a constant acceleration AB. So it's moving with a constant acceleration. Neglect the mass of the cord and pulleys. Okay, so clearly what's happening is, because the force vectoring F is shortening this length, that's increasing the length over here, the string length is increasing here, that causes the mass m to rise up. So you have to find F such that acceleration is constant. Okay, so this looks like a very similar problem, like what you might have seen in the earlier chapter 12, when we were talking about absolute motion. Right? The difference between this question and the previous chapter question is that in that particular question, you would be given the acceleration of this point, and you'll be told to find the acceleration at some other point. In this case, you're not given the acceleration, but you're given the force. So when you see a force, it's a Newton's law problem. Okay, so we got to use Newton's law. So that means we got to start with the free body diagram. Okay, so let's draw the free body diagram for the mass. mg acts downwards. There is tension in the cable, so let's call it T. So if I write F equals ma for that, I will see that I will have mg LFT, but I will not, the T would be an unknown, so I need to somehow relate that T I see over there with that F. So what I do is I draw a free body diagram for this pulley. Move it down. Okay, so it's the pulley. So that pulley is this one. When I cut this, that's what I do in a free body diagram. There's the tension acting upwards, there'll be an equal and opposite reaction T acting downwards. and there'll be two strings. And since the pulley is massless, I can assume that the force acting on the left is the same as the force acting on the right. Okay, this F being the same is a consequence of this pulley being massless and the string actually being unstretchable, inextensible. So let's call this angle theta, which needs to be found, and try to write an expression for F and T. So equations of motion. So this is the pulley, this is the mass for pulley. Okay, clearly there is equation in the x and the y direction. In this case, we are only interested in the y direction, so I will not write the equation for the x direction because there's no motion in the y direction for the mass m. So for the pulley, we have T acting downwards, so let's call that negative. There's F acting upwards, so F cosine theta is the force acting in the upward direction. But there are two forces, so there'll be 2F. And I'm going to put a positive sign because it acts in the upward direction, which is positive. So the net force is, well, if the pulley had a mass, it would be mass times acceleration. But since the pulley has no mass, the mass is 0. This will be true. Okay, so I know F, T is unknown, theta is unknown. Let's try to find theta using the geometry of the figure. So theta is this. So can you write an expression for cosine theta? So cosine theta is this side, which is d divided by 2, divided by the hypotenuse. So that's going to be y square plus d squared divided by 4. Or I can simplify this as d divided by, I think it's 2d divided by 4y squared plus d squared. So I'm just taking this 4, multiplying it there, that 4 comes out, and it cancels with this 2 to give a 2. So I can put this in here and solve for t. So t equals 2f cosine theta, so 4f okay. Now I can write the equations of motion for mass m, mg. So the mass is moving upwards, right? So t is positive because it's upward, mg is negative, it's downwards, and m times ab. Your question? Okay. Okay, so I know t because I just solved for it. So 4fd t square minus mg equals mab. Okay, so the question asks me to solve for f. So solving for f gives me, I'm almost done, I just have to write the expression for f. Mass times g plus a. So there's a couple of steps. I want you to go and slowly solve it. So going from here to here requires quite a few steps, taking that to the right side and then moving things around. So that's the answer. Okay, so I'll post these. Please study for the exam. We'll do a review. We'll have a review session tomorrow, on Wednesday, and also on Friday.